One type of compound inequality involves or. So in this situation, we have two inequalities and they're separated by the word or. Or you could be using the symbol or like this. So we have 3t plus 2 is less than -7 or -4t plus 5 is less than 1. So in this situation, you can kind of picture it like covering up one equation and just solving them separately. So I'm going to solve them one at a time. So the first one I'm going to solve is this one. So I'm going to do -2 minus 2. 3t is less than -9. Then divide by 3. So we're left with t is less than -3. Then on the other side, we have to solve this inequality. So we're going to do -5 minus 5. -4t is less than -4. And then remember, when you divide by negative here, sorry, I'm supposed to say divided by -4, we are going to flip the sign. So you're going to now make it a greater than sign. Still in the middle of both of these is the word or. So when we graph this, we're going to graph a number line that has -3 on it and 1 on it. And if you want to put 0 in there somewhere, you can. So we're going to graph both of these on the same number line. So I'm going to graph that t is less than -3. So I'm going to start at -3 with an open circle. And then if it's less than, I'm going to go to numbers smaller than -3. And then for 1, I'm going to also do an open dot. And then now I have t is greater than 1, so I'm going to graph numbers greater than 1. Since it's or, we keep everything the arrows touch, so I'm going to keep this whole number line. So that your final answer is t is less than -3 or t is greater than 1, and then this number line. You could also write that using interval notation. So just a reminder on how to do that. It would look like we start from left to right, so you'd be going -infinity to -3, not including -3, and then this is the symbol for or, and then it hits 1, and then it goes on to infinity. The next one we have is this inequality or this inequality. So I'm going to solve them separately. So we've got -7, -2, y is less than -6, and then divide by -2. Remember, when we divide by the negative, we're going to flip the sign, so it's no longer a less than, now it's a greater than. And we've got 3. Then we're going to solve the other side, so -3. So 4y is less than or equal to -8. Divide by 4. Sorry about my handwriting, team. Sometimes a struggle on this thing. And then -2. We still have the word or in the center there. So when we graph this, we're going to put both the 3 and the -2 on the number line. And then if you want to stick 0 in there, you can. And then we've got greater than 3, so y is greater than 3. So it's an open dot at 3, number's greater than 3. And then a closed dot at -2 because it's equal to, and then less than -2. It's an or, so we keep everything, so everything stays in the number line. So let's check out two kind of special cases. So here they've already solved it for us, so all we have to do is graph this. So we've got 2 and 5, 0 would be over here somewhere. So we've got x is greater than 2. So I'm going to do an open dot at 2, and then numbers greater than 2. And then x is greater than or equal to 5, so I'm going to do a solid dot at 5, and then greater than 5. Because this is an or situation, we keep everything, so this whole graph is our answer. So instead of 2 arrows facing out, now we've got just this whole line pointing forever to infinity. For the next one, I've got -2 and 1, and then 0's in here. If I started with x is less than or equal to 1, we've got a solid dot at 1, and then less than 1. And then an open dot at -2, and then it's greater than -2. So we're going to go greater than -2. So right now what we've graphed is everything on this line. So we are, because or is everything, So we ended up having to graphing like all the numbers on a number line. So we've got all real numbers here because of the OR situation. All right, now that you've seen some examples of OR, why don't you try some practice problems, and then we'll look at AND situations.